All right, let's talk about one of the most incredible stories in our evolution, the development of our big brains.
So in our last explainer, we established that we're all great apes, and that whole group is known for having, relatively large brains. But our direct ancestors, the hominins, took that trait and just ran with it. They took it to an absolute extreme. The thing is, this amazing brain of ours is a really, really metabolically expensive organ to keep running. So today, we're going to dive into the adaptations that actually made that huge increase in brain size possible.
First, we'll look at the encephalization trajectory, basically the story of how our brains grew. Then we'll cover the brain's high price, that metabolic cost we just mentioned. After that, we'll see how our ancestors started paying that bill, first with a major dietary shift, and then with a whole new way of birth. And finally, we'll wrap up with a cognitive payoff and see what all that investment got us.
Okay, so let's start with that trajectory. We're talking about a massive increase in brain size here, a fourfold increase, in fact.
And this timeline, well, it really tells the story. If you go back about 3.5 million years, an ancestor like Australopithecus afarensis had a brain around 434 cubic centimeters, not much bigger than a modern chimp's. But then, things start to pick up speed. By 2.5 million years ago, Homo habilis is up to around 650 cc. Then comes Homo ergaster with another jump to about 871 cc, and the trend just keeps going. Homo heidelbergensis 500,000 years ago is at 1200 cc, and then you get to us, Homo sapiens, with an average around 1400 cc. It is a clear, dramatic, accelerating curve upwards.
All that growth created a huge biological problem. A brain like that has a serious appetite for energy.
And this, right here, is the core of the problem our ancestors had to solve. To put it in perspective for us, today, our brain is only about 2% of our body weight, but it uses up a whopping 20% of our energy when we're just sitting around. So you can imagine the evolutionary pressure of trying to fuel that kind of organ as it got bigger and bigger over millions of years.
It helps to think of this as a kind of biological budget. A bigger brain demands way more energy. The problem was, early hominin diets just weren't very energy-rich, so that extra energy had to be pulled from other bodily functions. Our ancestors had to find a way to afford this luxury organ.
So, let's look at how they started to pay that bill. The first major solution was a complete shift in their diet. They had to find a higher energy income.
And this really shows the difference. The early hominin diet was mostly plant-based, tougher foods like tubers, which are pretty low in energy density, but later on with the genus Homo, while the plant-based foundation was still there was a huge increase in their reliance on meat. And meat is just packed with high energy calories and fat, making it a much better fuel source for a growing brain.
The key to unlocking this new diet was technology. The whole process starts around 2.5 million years ago with Homo habilis and the first appearance of what we call Oldowan tools. These are pretty simple choppers and scrapers, but these tools were a complete game changer. They gave our ancestors a way to access new foods. They could butcher carcasses they scavenged, cut off the flesh, and, this is super important, crack open the bones to get at the incredibly fatty, calorie-dense marrow inside. This new, energy-rich diet provided the fuel needed to support a larger, more complex brain.
Okay, so boosting their energy income with a new diet was a huge step, but it was only one part of the solution. They also had to restructure the costs, and this led to another profound adaptation, one that changed our entire life cycle, a totally new way of being born.
And this is where we see a major evolutionary trade-off, what's called the obstetric dilemma. See, as we evolved to walk upright, our pelvis became narrower to be more efficient. At the exact same time, our brains were getting bigger, which means babies' heads were getting bigger. You can see the problem here, a wider head trying to pass through a narrower birth canal. These two evolutionary trends were on a collision course.
The solution was, well, evolutionarily speaking, pretty brilliant. Hominins started giving birth to neurologically immature infants. We call this having altricial young. It means being born in a really undeveloped state, needing a ton of parental care. A human baby's brain continues to grow massively after birth. This was the workaround.
And we can actually see this in the fossil record. When we look at a species like Homo ergaster, we find a relatively small birth canal compared to their adult brain size. This strongly suggests that a long period of postnatal brain growth and juvenile dependency was already part of their strategy. This adaptation didn't just solve a biological problem, it completely reshaped hominin society, demanding huge parental investment and setting the stage for the complex social structures we have today.
So, after this massive dietary change and a complete rethinking of how we're born, we have to look at the payoff. All of these high costs, what did our ancestors get for it?
The advantages were, well, they were everything that makes us who we are. That bigger brain led to much more sophisticated technology, moving from simple choppers to finely crafted spears. It enabled a massive reliance on culture, the ability to create, share, and pass down knowledge between generations. It also laid the groundwork for the capacity for language, for complex communication that allows for incredible cooperation and planning. And it led to advanced social behavior. We see evidence of our ancestors caring for the old and the sick, like in fossils such as the toothless Homo georgicus skull from Tremonzi. That individual couldn't have survived alone, which tells us their group was caring for them.
In the next video, we will learn more about great apes and their unique characteristics. It will help us to understand more about human evolution.